Hello and welcome to Mechanical Y. Today we're doing a micro lesson on the law of cosines. The law of cosines is particularly useful when looking at triangles. Specifically, it is very useful in determining the length of one side of the triangle given the other two lengths and the angle between the two given sides. Now there are many ways to derive the law of cosines, but we're going to use trigonometry. And this derivation may look a little bit intimidating, but every individual step is actually quite simple and straightforward to do. So please bear with us. Alright, let's start with a right triangle. Now this right triangle has one right angle, and it has another angle that let's say is called alpha, and then sides C and B. Now we can write the cosine of alpha is equal to the adjacent side C over the hypotenuse of the right triangle B. Now this is an equation that is true for right triangles. But what happens when we have a triangle and we don't know if it's a right triangle? Let's say it has sides alpha, beta, and gamma, and sides A, B, and C. And we don't know whether this is a right triangle. How do we write cosines of these different angles? Well, we're going to have to use a little bit of a trick. We're going to have to make this into two smaller right triangles. And we do this by dropping a line that is perpendicular to B. So now we've split B into B1 and B2. So now we have two smaller right triangles, and we've split B into B1 and then B2. So now we can say that B is equal to B1 plus B2. We've just split it in half. And now we could take the cosine of alpha as B1 over C. So it's the adjacent side over the hypotenuse. And we can find that the cosine of gamma, sorry, this should be B2, the cosine of gamma is equal to B2, the adjacent side, over A. So let's rearrange these equations so we can get rid of B1 and B2. So this equation becomes that B1 is equal to C cosine alpha, and B2 is equal to A cosine gamma. So now we have two equations, one for B1, one for B2. Now we can plug it into our first equation and get rid of B1 and B2 altogether. So we're left with that B is equal to C cosine alpha for B1 plus A cosine gamma for B2. So now we have one equation. But we need to repeat this procedure for the other two sides. So let's say we have the same triangle as before. And let's say it has the same angles as before, alpha, beta, and gamma, and then sides A, B, and C. We're going to repeat the procedure from before of drawing a line that's perpendicular to one of the sides, but we're going to pick a different side, in this case A. So we're going to take a line to A that is perpendicular, and we split A into A1 and A2. So just like before, we can say that A is equal to A1 plus A2. So all we did was split A in half, and now we got two smaller right triangles, one down here and one up here. And we can, just like before, we can now start writing cosines of some of these angles. So we can get that the cosine of beta is equal to the adjacent side A1 over C. And then likewise for gamma, we get that the cosine of gamma is the adjacent side A2 over B. Now, just as before, we can rewrite these to get rid of A1 and A2. So we get that A1 is equal to C cosine beta, and A2 is equal to B cosine gamma. So now we have two equations, one for A1 and one for A2. We could plug it into our original equation, and now we can write A as A1, so C cosine beta, plus A2, which is B cosine gamma. So now very quickly we can repeat this procedure for the same triangle with the same angles, alpha, beta, and gamma, and sides A, B, and C. We can drop the perpendicular just like before and split C into C1 and C2. And just like before, we can say that C is equal to sum of C1 and C2. And starting to get some of the cosines, we can say that cosine beta is equal to the adjacent side C1 over the hypotenuse A, and then cosine of gamma, alpha rather, cosine of alpha is equal to the adjacent side C2 over B. Just like before, we're going to rearrange these equations so we can simplify the equation above, and we get that C1 is equal to A cosine beta. And we get that C2 is equal to B cosine alpha. Now we could take these two equations, one for C1 and one for C2, and plug it into our original equation up top, and we can get that C is equal to C1 plus C2, which is equal to A cosine beta plus B cosine alpha. So now we have three equations. Let's rewrite them so they make a little more sense to look at. So we have that A is equal to C cosine beta plus B cosine gamma. And that's what we derived right here. We have that B is equal to C cosine alpha plus A cosine gamma. And that's what we derived right here. Then we have that C is equal to A cosine beta plus B cosine alpha, which is what we derived down here. So now we have three equations. And notice that there is some repetition in these equations. There's a pattern. Everything is given in terms of the original values from the triangle. So all the B1s, B2s, A1s, and A2s, they all disappeared. And you notice that everything is also given in terms of cosines, which is what we want. But we can't really use this as it is. We need to take one more step to make this a little bit more useful. So this is where a little bit of math manipulation comes in. We're going to start with the first equation for A, and we're going to multiply it on both sides by A. So we get that A squared is equal to AC cosine beta plus AB cosine gamma. Now we're going to repeat this with the other two equations. So with the second equation, we multiply both sides by B. And what we get is B squared is equal to BC cosine alpha plus AB cosine gamma. And repeating the same procedure with C, multiply both sides by C, we get that C squared is equal to AC cosine beta plus BC cosine alpha. So now we have three new equations, and all we did was some very simple math to the original equations that we got. But now you'll notice that there are a lot of patterns here. We have squareds on one side, and then we have AC cosine beta here, AC cosine beta here, BC cosine alpha and BC cosine alpha, and here these both have AB cosine gamma. So now we see a lot of patterns, and we can think that we can combine these in such a way that we can get rid of some of these terms. Get them to drop out, disappear, or cancel each other out. So let's start with two of these equations. Let's start with A squared, and let's subtract C squared. So what does that look like? We get AC cosine beta plus AB cosine gamma, and that's A squared. And we subtract AC cosine beta minus BC cosine alpha. And this is subtracting the C squared term. Now, you see that some of these terms actually cancel out. So we get that AC cosine beta and then minus AC cosine beta cancel each other out. So now we're left with A squared minus C squared is equal to AB cosine gamma minus BC cosine alpha. Now it doesn't look like we've gotten very far here, but if you look closely, AB cosine gamma and BC cosine alpha are the same terms we have in the B squared equation. So now let's take one more step. We take this equation that we had before, and we're going to add B squared. So what does this look like? We get the original equation, AB cosine gamma minus BC cosine alpha. So that's the A squared minus C squared term. Now we're going to add B squared, and we get the B squared term from up here. So it's plus BC cosine alpha plus AB cosine gamma. Now again, you'll notice some repetition. You have an BC cosine alpha term here and a minus BC cosine alpha term here. So these two terms drop out. Now you'll notice that here you have two AB cosine gamma terms. So let's add them together. So now we can rewrite this equation as A squared minus C squared plus B squared is equal to 2 times AB cosine gamma. Let's rearrange this so it's a little more useful. So we get that C squared is equal to A squared plus B squared minus 2AB cosine gamma. All we did was rearrange this equation before. And what are we left with? This is the law of cosines for side C, given sides A and B and the angle between them, gamma. Now we can very easily repeat this exact procedure, just combining A squared, B squared, and C squared in a slightly different way to get this equation, but solving for A squared and B squared. So without deriving them completely here, I'm just going to say that A squared is equal to B squared plus C squared minus 2BC cosine alpha. And that's the same as this equation, just solved for A squared. And likewise, B squared is equal to A squared plus C squared minus 2AC cosine beta. Now these are also part of the law of cosines. Again, we have the length of a side A given in terms of B and C, which are the two other sides, and cosine alpha, which is the angle between the two sides that were given, and same thing with b squared. So now, how is this useful? Well, this is an extremely useful relationship in the real world. Let's say I'm standing on the ground somewhere, and I see a bird or an airplane off in the distance. Now, I can use a rangefinder or some tool to tell me what the distance to that bird is. And let's call that A. So now I know the distance to that bird. At some later time, let's say that bird or airplane or anything else flies a little distance over. I can use my same rangefinder as before to find out the new distance to the bird, and let's call that B. Now I'm standing right next to where these two intersect, so I know how far I had to turn to look at the bird. So I know that this angle here is gamma. So I basically knew how far the bird was at one point, and then turned by angle gamma after the bird flew a little distance, and now I know how far it is at the second time. So now I could use this, plug it into this equation here to find out how far did the bird fly. Now this is useful for tracking things like birds, tracking things like airplanes, other objects moving through the air, or even objects on the ground, where you can tell the distance from yourself to one point, and then yourself to the point at a slightly later time. Given the angle you had to turn, you can now find out the distance between those 2 points. This is extremely useful in the real world. So let's look at a special case. Let's take this triangle and let's squish gamma so it becomes 90 degrees. So we take this triangle and we've squished gamma. So now gamma is 90 degrees. But we still have sides alpha, beta, and then sides A, B, and C. Let's apply the law of cosines. So we have that, and let's apply it around gamma. So we get that, and C. So we get that C squared is equal to A squared plus B squared minus 2AB cosine gamma. So all we did was apply this equation to this triangle here. But we know that gamma is equal to 90 degrees. So cosine gamma is equal to cosine of 90 degrees. And we know that the cosine of 90 degrees is equal to 0. So what happens to this equation? Well, if this is equal to 0, then this whole term drops out. And we are left with C squared is equal to A squared plus B squared. And this, if you'll recognize, is just the Pythagorean theorem. So the Pythagorean theorem is just a special case of the law of cosines. Thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on future micro lessons.